without plugging anything in. So the first one says log base 2 of x given that x is 32. So what is this asking me then? It's saying log base 2 of 32. So 2 raised to what power is 32? Well, you get 2, 4, 8, 16, 32, right? So it'd be 2 raised to the 5th power. So my answer here on A was asking log base 2 of 32. And the answer there is 5. Okay? So we see, again, I just want us to practice them without the calculator for now. I'll show you how you can put these in your calculator in just a second. B part, log base 3 of x given that x is 1. So what am I asking? 3 raised to what power is 1? 0. Anything raised to the 0 power is 1. So 3 raised to what is 1? The answer there is 0. Okay, C part is asking log base 4 of 2. So this is saying 4 raised to what power is 2? What did you say? A half? Because what is a half power? Half power is the same thing as what?
Multiplied or divided by.
What does an exponent mean? That tells me how many times I'm going to multiply by itself. So how can I multiply 4 by itself half a time?
2.
Okay, well what is 9 to the 1/2 power?
3.
Don't use a calculator.
3.
So what am I doing with a 1/2 power? Yes.
Oh, because
Raised to the 1/2 is the same thing as a square root.
this is a fraction. Okay.
So on this one, 4 raised to what is 2? Well, I'm taking a square root, right? The square root of 4 is 2. So that means my answer here is going to be 1/2. Okay, and then D part, I've got log base 10 of 1 over 100. So this is saying 10 raised to what power is 1 over 100? No. Because that would be taking a 10th root. So if you're taking roots, your number's going to get no, it's not a 10. I don't have a good explanation. You're wrong. That's all I got. Okay?
100.
No.
Negative 2.
Yes. How you know?
Because negative exponents go back to decimal.
Yes. So if I have 10 raised to something that's equal to 1 over 100, well, let's try to rewrite 100 as 10. Can we do that? 100 is 10 squared. So I have 10 raised to what power is 10 squared? Well, we haven't done this year, but hopefully you've done it before. If I move a exponent from the denominator to the numerator, or from the numerator to the denominator, I can always change its sign. Okay, so for example, if I have 10 to the third, I can rewrite that as 1 over 10 to the negative third. Anytime it swaps from numerator to denominator, we can just change the sign of the exponent. And it's an equivalent expression. So 10 to the third is the same thing as 1 over 10 to the negative third. So right here, because I had 10 squared in the denominator, I move it to the numerator, it becomes the negative second. So that means 10 raised to what is equal to 10 to the negative second? Well, the question mark needs to be -2. Right, so my answer here would be -2. Have y'all seen negative exponents before? Algebra 2? You should have. You should have. Okay? So you're going to have to know how to do these, how to work with them. So if you don't know that, you need to make yourself a note. Because we're going to be doing a lot with this next section. About how negative exponents work, how we can move them from numerator to denominator. But for right now, I'm going to show you how you can put these in your calculator. So if you have a Casio, you can put all of these questions exactly in your calculator, and it'll do it for you. Okay? Which is nice, but it also stinks. Why does it stink? Because y'all don't understand how it works. Y'all just plug it in and say, I got it. Okay? Bad. Because when we're going to start working with variables everywhere later. And so you have to understand the process. What is it asking me? Because I'm going to have to solve for a variable. Will your Casio do that? No. So you got to understand the process of how we can rewrite. That's why I'm making sure here you understand what questions are being asked. 4 raised to what is 2? 3 raised to what is 1? Right? That's how logarithms work. That's the questions that it asks. A. 0. A should be 0. And C part. 10 raised to what power is 10,000?
10, 3.
Okay, so let's think about it. 10 to the first power is here, right? This is 10 to the first power. So I need to move the decimal 1, 2, 3 times. So that means this is 10 to the second, 10 to the third, 10 to the fourth. So 10 raised to what power is 10,000? That should be 4. So this says the logarithmic function with a base of 10 is called a common logarithmic function. On most calculators, this function is denoted by log. Example 2 shows how to use a calculator to evaluate common logarithmic functions. You will learn how to use a calculator to evaluate logarithms with any base in the next section. Okay? So, right here, if you ever see, right now they've got it written out. F of x is log base 10 of x. But because it's a common logarithm, we can just write this as log of x. If you ever see a logarithm without a base, it's an understood 10. 10 is its default. Because what base number system do we work in? We work in a base 10 number system. So if I don't write what it is, it's understood to be a 10. It's kind of like when you take a radical, what root are you taking? Understood. A second root. Right? You don't have to write it, it's just understood. Same difference here. I don't have to write a base 10. If there is no base, I understand it's a base 10. So this is saying, let's see how many of these we can evaluate without a calculator, but some of them we're not going to be able to. So right here, if I plugged in 10 for x, that means I am taking log of 10. So what's this asking? 10 raised to what is 10? The first power. Right? 10 to the first power is 10. So notice what kind of happened there. If I take log base 10 of 10, it's almost like these cancel each other out. Right? Log base 10 of 10. Because what am I asking? 10 raised to what is 10? Well, that's 10 to the first. So it's kind of like it's gone. It becomes a 1. Like a division. Not canceling. Okay, if I look at B part says log of 1/3. So that means 10 raised to what power is 1/3? Ugly. I have no idea. Okay, I can't do that without a calculator.
-0.477.
You plug it in, or you just know it like that?
I'm just guessing.
No, I don't know what it is either.
Random number.
So in your calculator, so I'm going to show you on this one, on the TI, the log button is right beside the 7. So everybody say log. So I can click log of 1/3. So I'm going to do 1 divided by 3 Oh, wow. Look at you, Hall. You're just a math whiz. Who would have known? So that would be negative 0.477. C part. If my x was 2.5, that means 10 raised to what power is 2.5? Well, I don't know, but I'm going to put that in my calculator again. Log of 2.5. That's going to give me 0.398. And then D part. If I do log of negative 2. Okay, let's not put this in our calculator. Let's think about it for a second. 10 raised to what power is negative 2? Well, how can I take a positive number, raise it to something, and get a negative answer? You can't. Okay? If you put in your calculator, log of negative 2, it says error, non-real answer. Alright, so you're getting into the imaginary realm. So my argument cannot be negative. That's fine. Undefined, error,
No solution.
no real solution.
Does not exist.
It does exist.
Well,
It does exist.
technically it'll be D and E.
It does exist. Again.
Oh.
No, you can, it's not real.
It's imaginary.
It's imaginary. No. It's in your calculator. Right? I'm going to put the answers up there. Please go get some water.
Bro, do you need a blue power agent?
Simplify logarithms. So you look at the first one. If I have log base A of 1, the answer is always 0. Because any base raised to the 0 power is 1. Right? And we've talked about that. A raised to what is 1? Well, that's always going to be 0. When you look here, A raised to what is A is 1. Right? We looked at that too. We had log base 10 of 10. So those cancel and become a 1. Okay, let's look at this one. Log base A of A to the x is x. Okay, so we've talked about it here, right? That log base A of A essentially cancels and becomes 1. Okay, now this one here, whenever I have an exponent inside my argument, I can move it to the front as multiplication. So this is the same thing as x times log base A of A.
I think we did this.
You have done it.
Yeah.
Now you have log base A of A is 1. 1 times x is x. So what they're saying is log base A of A to the x is just x. And then similarly, A raised to the log base A of x, same logic. This becomes 1. And you're left with just x. Okay? So whenever you have A raised to the same base as a logarithm, or when you have log base A of the same base. Okay, and then let's look at the fourth one. It says if log base A of x is equal to log base A of y, well that means what? X has to be equal to y. Because you have log base A's on both sides, you can just drop them. And you can set the arguments equal to each other. X is equal to y. Properties. So when I look at A, it says log base 2 of x is equal to log base 2 of 3. So because I have log base 2's on both sides, they can cancel, which tells me x must be equal to 3. Questions on A part? B part, I have log base 4 of 4. Well, log base 4 of 4 is just 1. So I have 1 equals x. And again, that makes sense if you think about what it's asking. 4 raised to what is 4? 1. Alright. Next, C part. Log base 5 of 5 to the x. So we can move the x out front, which means I have x times log base 5 of 5. Well, log base 5 of 5 is 1, which leaves me with just x. And D part, 7 raised to the log base 7 of 14. Well, 7 raised to log base 7 essentially cancels out, which leaves me with 14. Okay, try these two. So this goes back to something that I have to teach my 7th graders. Notice how this one says solve and this one says simplify. So what's the difference? Yeah, very good, Jack. The first one you're going to solve, the second one you're going to simplify.
Makes sense to me. Good job, Corey.
Do y'all know the difference? If you said solve or simplify, what's the difference?
Solve is looking for like x, and simplify is looking for x.
If it says solve, your goal is to isolate the variable. You're going to have the variable equals an answer for solve. For simplify, you're just breaking it down. There, you don't have to have x equal something. Simplify means there is no equal sign. Solve means there is an equal sign in your answer. Okay?
It's like factor, you're not trying to, you're just trying to factor it.
Yeah. So what did we get on A part? X equals 2. Any questions there? B part, what did we get? Any questions there? Okay, so look at this. To sketch the graph of y equals log base A of x, you can use the fact that graphs of inverse functions are reflections of each other in the line y equals x. So what they're wanting us to realize here is we talked about inverse functions. Inverse functions are just reflections of each other over the line y equals x. So let's go ahead and graph this. So I want to graph 3 things here. So I'm on my calculator. Let's click zoom. And let's go to zoom standard. Click 6. Okay. Then we'll click y equals. Clear that out. Now the 3 things we're going to graph. Let's graph 2 raised to the x. Just remembered we can't graph this. That's great. Wonderful.
We can't graph this. So why we put it in here?
Hey, good question. Okay, let's click y equals x as our second one. And let's graph those 2. So I've graphed 2 raised to the x and y equals x.
What do you mean I can't graph it?
Well, I'm going to show you in just a second what I mean. You can graph those 2 things. We can't graph C part. Okay? So when I graph those, this is what I get. Right? Now, the graphing calculators, the only bases of logs that you can use are 10 and E. Because this is a log base 2, your graphing calculator will not compute. Cannot work. So what they want you to know is, if you know what 2 to the x looks like, and you know that inverse functions are just reflections over the line y equals x, then that means this graph, log base 2 of x, would just be a reflection over this line. Right? So it's going to be here.
Just go the opposite way.
Like that. Imagine flipping it over that line, y equals x. That is its inverse. So, one thing that I like to do is I like to find a few points that makes sure that I'm doing this correctly. So like, you see how this point here is 0, 1. The inverse means 1, 0 must be a point. Because inverse means we swap the x and y. So I made sure I went through 1, 0. You can do that for other points as well. It's like you could go to like 2, we know 2, 4 should be on there, which means 4, 2 should be on my graph.
So you just flip the coordinates.
Inverse, that's what inverse is. It's changing the x and the y. Okay? Now again, I've told you, I don't care as much about these graphs. I just don't. Because I don't remember ever using them for any other class besides this. So I'm not going to be real strict on these graphs. The whole reason I'm giving you the graphing calculator to begin with. That we could graph that are base 10. And let's look at transformations where we can tell what's happening before it ever gets there. So like, look here. If I had log base 10 of x, my log base 10 of x graph is here. It's in gray, right? We've got basically a vertical asymptote here at 0. We're going through 1, 0. And then we are working in this direction. Now, that's log base 10 of x. So what do you think log base 10 of x minus 1 would do? Is this on the inside or outside? Inside. So it's going to affect the x's. It does the opposite of what it looks like it should do. So minus 1 means I'm going to move right 1. So log base 10 of x minus 1 is here. You see how I've moved the graph right 1. Same stuff we've been doing all year. Here, this is a plus 2 on the outside, which means I'm going to affect the y's. And that does what it looks like. So plus 2 means I'm going to move the graph up 2. So here's the original, log base 10, and here is the plus 2, what that looks like. Okay. Now again, these log base 10s, we can see exactly what it looks like because we can graph them in our calculator. So let's put these in our graphing calculator. Let's do all of them at once. So let's do log base 10 of x minus 1, log base 10 of x, and then 2 plus log base 10 of x. So I'm going y equals, clearing, and I'm going to put those in. Log base 10 of x. Then I have log base 10 of x minus 1. And then I have log base 10 of x. And then I have a plus 2 at the end. Or I could put it at the beginning. It doesn't really matter. Okay, so when I graph these logarithms, we can see what happens. So where we have that vertical asymptote here, we know the graph sharply comes down and follows it. Now it doesn't go in an exact horizontal line. It doesn't go in an exact vertical line, because if it went straight down, then it would not be a function, right? It wouldn't pass the vertical line test. But it's basically going straight down. It's getting really, really close, and just barely closer. But this graphing calculator can't show it in its normal form. If I wanted to see that vertical asymptote, I would need to zoom in on the graph. So we can see if I click zoom in, and then I'm going to zoom in, like I'm making my y value be like -4, and click enter. Let's see if that worked. Still didn't work. Zoom in. Still didn't work. Okay. So, because it's fallen so sharply, the graphing calculator can't even show it. But we know that there's a vertical asymptote here, and we know that the graph's approaching and falling off right there as it approaches 0. A base of e, that's called our natural logarithm. So, let's talk about that very quickly. So if I had this, if I had e to the x, and I wanted to rewrite it, then I'm going to write this as log base e of the answer, so I'm going to call this y, log base e of y would be equal to x. Okay? In calculus, this log base e is so common that they have shorthand for it. We don't write log base e, they write ln of y equals x. But when we write this, that's the same thing as log base e. That's just the way we write it. And we call it the natural log. Why do we call it the natural log? Because e is the natural number. So we're doing a log base, the natural number. Log base e, we call it a natural log. Right? So those are just used interchangeably. So again, this is a natural logarithm. If you're like me, I always had one question when I first learned about natural logarithms. Why is it ln and not nl? Natural log. Because it's like, what's that real fancy language that's extinct now that nobody speaks? Latin, there we go.
Jargon.
I'm pretty sure in the Latin, this is shorthand for Logarithmic naturale. I have no idea, I just made that up. But it's something like that, you can look it up.
Sounds Spanish to me too.
Sounds Italian to me.
Okay, so let's evaluate these. So when we plug in, these should be our answers. That we saw of regular logarithms. So just like we talked about, natural log, all of these natural logs, they all have an understood base of e. So even though we don't see it, all these natural logs have an understood base of e. So this is saying e raised to what is 1. Well, anything raised to the 0 power is 1, right? We talked about that all earlier. Right here, this says e raised to what is e. That's the first power. Remember we talked about that. When you have log base e of e, those essentially cancel out and become a 1. Now, if you look at 3, 3 says log base e of e to the x. So what did we talk about with these? If I have an exponent in the argument, I can move it out front for multiplication. It becomes multiplication. So I could rewrite this as x times the natural log of e. Well, again, the natural log of e, that's log base e of e, that cancels and becomes a 1. So we're left with just x. And then similarly, e raised to the log base e, those cancel and we're left with just x. Okay? Again, it's harder to explain this one, it's harder to show, so it's not even worth doing it, really. And then if I look here, if I have natural log of x equals the natural log of y, because I have logs on both sides that have the same base, I can just drop those logs, which tells me x is equal to y. Okay? So again, 4 of our basic properties of logarithms that we're going to get more in depth with after Thanksgiving. But we're doing the introductory level stuff here. Okay, so let's look at A. A, I've got the natural log of 1 over e. Well, I know if I have log base e of e, if this argument here was e, then it would cancel. But it's not e, it's 1 over e. So is there some way I could rewrite this to be just e?
I guess we could do the reciprocal.
Well, something like that. Yes. Because I have e to the first in the denominator, I can move e to the first to the numerator and change the sign of my exponent. You remember we had some problems like that on Wednesday. So this will be the natural log of e to the negative first power. Now when you move that e to the first to the numerator, you have to multiply it by 1. So, I mean, this time that's kind of useless because multiplying by 1 really does nothing.
Excuse me, teachers. Students, don't forget progress reports will go out Monday. So if you have any work that needs to be turned in, make sure you're getting that done so you'll have good grades on your progress report. Monday is the day. Thank you.
Thank you, Miss LaRue. Okay, so Now I have a -1 as an exponent in the argument. I can move that out front for multiplication. So I have -1 times natural log of e. Well, the natural log of e is 1. So I have -1 times 1, which is just -1.
You plug it in as natural log e to the -1. My calculator is getting -1.
Yes. Yes, but you have to learn these rules because you're going to start having variables. When we come back, there are going to be variables that you can't just plug into your calculator, but you have to do these same processes. So the reason I'm teaching it this way is because these are kind of like the baby step easy ones. Before you get to real complicated, I've got 3 variables and I'm trying to rewrite it so I can solve it. So yes, this one will plug in your calculator, but you also need to understand the process. If you don't, you're going to be behind when we get there. Okay, when I look at B, is there any other questions on A? Any part of that we're confused on? Look at B. What do I have? I have e raised to the log base e of 5. Okay, well, anytime I have e raised to the log base e, those are inverse operations. They cancel, and I'm left with just 5. E raised to the log base e cancels. Okay, so any questions on B part? C, I have 4 times the natural log of 1. So again, what does a log ask? It says the base raised to what is the argument. So without a calculator, this time my base is understood to be e. So this means e raised to what power is 1? 0. So I know that the natural log of 1 is 0. Because anything to the 0 power is 1. So this gives me 4 times 0, which is 0. Questions on C? Okay, similarly on D, what are we asking? We're saying the base, which is e, raised to what is e? 1. E to the first is e. So the natural log of e is 1. Remember the natural log of e, so that's log base e of e, that kind of cancels. That gives me a 1. Either way you want to think about it. So now I have 2 times 1, which is 2. What did we get on A part? What was the answer? 1/3. That is correct. Do I need to work A? Uh-huh. And remember, an exponent here, that's the 1/3, can come out front as multiplication. So I have 1/3 times the natural log of e, and then the natural log of e cancels out, which gives me 1/3. Any other questions on A? Okay, what did we get on B? 0. Any questions on B? We feel good with it? Well, you're not being very talkative. I don't have to go back to Siri, making me pick a person at random. Everybody's good with B? C. C should be 3/4. Right, because natural log of e, that's saying e raised to what power is e? That's the same thing as 1. So I have 1 times 3/4, which is 3/4. And And then D, I have E raised to the log base E. Those cancel, which leaves me with 7.